And we'll just begin by mentioning the statistics from the quiz that you guys just took this last class. The mean was 86. That's where we take all your grades and add them and divide by however many people took the quiz. The median was 89. If you were all standing in order of your grades on the quiz, the middle person got an 89, which means half of you did better than 89, half of you did lower than 89. High grade achieved by one person was 100. We'll start today on page 138 in the blue. And at some point during class, I'm going to walk around and check some homework. I've only checked a couple of people's homework right now. So there was homework due today. I didn't mention it last class during the quiz day because I forgot that there was homework due today until after the quiz. So if you didn't do the homework because you didn't realize there was homework, that's okay. I'll take it on Monday. But we'll just take our quick look at the schedule. So you can see highlighted here, 2-4 is what is due today, but I'll take that on Monday if you don't have it. And 2-5 is what's due on Monday. That's what we covered today. Any questions on the schedule? Okay, then let's go ahead and start on page 138 in the blue. And here we are. Okay, can we begin with Dan, the objective?
In this lesson, we solved multi-step equations involving both positive and negative numbers.
Okay, so in theory, there isn't anything new today. We've already solved multi-step equations and we've already solved application problems that will look quite like the ones that we're doing today. The only difference is before we kept the negative numbers out of all these problems and equations, and today the negative numbers are coming in. So we'll go to number 1. Can we go to Lauren? Amy? Okay, so give this a shot. There's not a heck of a lot of information in there and 2 blanks to try to fill in. So check with your neighbors and we'll come back together in just a few moments. So second word is variable. First word also starts with a V. Any ideas? It's the value. Good. So Amy, can you read the sentence with the blanks filled in now? Okay, so that seems okay. Just looking for numbers that make the equation true when you replace the variable with the number. Okay, so let's try number 2. We're going to solve these equations. These are multi-step equations. We'll do them together real quick, and then you guys will have lots of opportunity to do problems in your groups. Okay, so looking at this first equation, 13 minus 8x equals 28. I have a 13 to contend with, and I have a negative 8 to contend with. Which is the one that we need to move first? It's the 13, and I'm hoping we're clear on why it's the 13. If it helps you, go ahead and make that do list. I don't need you to make a do list, but if you were plugging in x equals 17, for example, you would first multiply by negative 8. I'm going to write that. First multiply by negative 8. And then you would add 13 to your answer, right? If you were plugging in a number for x. So when we undo, we got to go the other direction. So we got to get rid of that 13 first. Okay, so subtract 13 from both sides. At some point, I'm going to stop insisting that you write subtract 13 from both sides, but that point is not today. So please continue to write it for now. And on the left-hand side, what do we have? Negative 8x, thank you. Right-hand side? 15. And then how do we get rid of that negative 8? We divide. Divide both sides by negative 8. And so there isn't really anything new here. Like I said, we've done equations like this before. The only difference is that up until now, Sandy and I made it so that that negative 8 was a positive number. And it's negative, but it's not a big deal. Okay, what do we have on the left-hand side? Just x. That's the point, is that we cancel those negative 8s. Now, some folks end up wasting time fiddling with this thing on the right-hand side, not recognizing that 15 over negative 8 is a perfectly good answer, and we're done. Some people change that into a mixed number, like -1 7/8. I mean, it's correct, it's equivalent. -1 7/8 is the same as that fraction, but number one, there's no need to go that extra step. Number two, if you actually have to do anything with 15 over -8, it's better to have it in that form than to have it in the mixed number form. Some people would go to their calculator, type it in to get a decimal, or they would do long division to get a decimal. There's no reason to go that step. I mean, sure, it's -1.875, but this is fine. And I think it's quite nice to leave it as a fraction. Okay, moving on to the second one. -2 equals 4 minus 5x over 7. We have a 4, we have a negative, we have a 5, and a 7. What needs to move first? Let's move that 4. We'll subtract 4 both sides. We get -6 equals -5x over 7. And I think that at this point, there's one very nice, quick way to finish this problem. And then there are lots of other ways, some of which are right and some of which are wrong, which are other options at this point. I see a -5/7. In one step, I'm going to multiply by 7. And what else am I going to do? Let's divide by -5. You can do them both in one shot. Now that I'm saying that, I realize actually we probably haven't done something like that before. So how about we do exactly what Chris had said? That's a natural thing. Multiply both sides by 7. And that will get rid of the 7 in the bottom. On the left-hand side, what do we have? -42 equals, what happens on the right-hand side? We just get -5x, right? Those 7's cancel. There's no reason to do 7 times the 5. And it's completely wrong to do the 7 times the 7. That 7 is only upstairs, but don't even bother multiplying it. Just cancel it right away with the 7 downstairs. And then finally, how do we move the -5? Divide both sides by -5. X equals. Okay, given what I just said about fractions and mixed numbers and decimals, how would I like you to write this answer? As a fraction. What fraction? -42 over -5. You just leave it. It would. So actually, I would probably take a point off if you left it in this form. I'm not saying I want mixed numbers. I'm not saying I want decimals. I want this. But the only other thing is that we want our answers to be simplified. And anytime you see a negative divided by a negative, it's kind of your obligation to cancel them both and make them positives. So 42/5. Okay. And then the last equation, -16 minus x equals 11. It looks even simpler than the one we just did, but there's a reason we're including it here. So what do we do first? Let's add that 16 to both sides. So we get -x equals 27. Yeah, that's the right thing to do. We've got a -x. It's pretty common to have a -x towards the end of a problem. We just got to handle it. We have to know what to do with it. So what you could do, I'm going to write something, but then I'm going to suggest you write something different. You could divide both sides by -1, because isn't there an invisible 1 sitting right there? And so we can just divide both sides by -1, and then recognize that 27 over -1 is really the same as what number? Is -27, right? Okay, I said I was going to encourage you to write something different. I think Olivia's suggestion is a very natural one. I'm going to do something a little bit unnatural, and I'm going to suggest instead of dividing by -1, you multiply by -1. And it's kind of a weird thing to do. You could do either one, absolutely, yeah. but I'm going to do this. What happens when I multiply two negative numbers? It becomes positive, and that's all I was after, was make that negative x a positive x. So I've accomplished that goal. The left-hand side is just x. How much is 27 times negative 1? Is negative 27. And I would just say that, and so we get the same answer we got before. And both answers are totally fine. And Olivia's is more natural than what I've written up here. But I just think it's probably a little bit more accurate for folks to do 27 times negative 1 than 27 divided by negative 1. I just feel like multiplication is easier than division. Either way is fine. Any questions on those? Okay, so classwork is here. Lots of time to work through all the problems, so give it a shot. We'll come back together in a little bit. What was the answer to part C? Sorry, what was the answer to part B? Was m equals 8. And what was the answer to part D? M equals negative 7. Right, so most groups I think have already finished that. It's okay if you haven't quite, but you do the algebra, and eventually you get to these two numbers. So what I wanted to talk about together was what the sentences are. What do those numbers mean? So here, the important phrase in this problem is that we want M to represent the number of minutes from when the tea was poured. This is a definition in this problem. M is the number of minutes from when the tea was poured. So I'm going to put 0 for M right here. What special thing happened at that moment in time? That's when the tea was poured. Okay, so the tea was poured, and we're just defining it at m equals 0. It's like somebody's standing there with a stopwatch, and they start the stopwatch right when the tea is poured. And if you are to the right, if you are any place here, what non-math word can we use to describe all of that space? Well, positive is a math word. After, right? After. So anything out here is after. After what? After the tea was poured. And another non-math word to describe all of this space. Before. Before what? The tea was poured. So we're going to have a lot of problems coming up in the next bunch of classes that have to do with time. And we're going to have a 0. And that 0 is associated with the keyword when. When the tea was poured, when the ship left the dock, when the plane took off, when you started the quiz. That when is the keyword for 0. Okay, so maybe I can highlight when goes with 0. It could be right now is yes. And then if you have a positive answer, it's after the event. Not just generic after, but after something happened, after the tea was poured. And then if you have a negative answer, it's a before the event. So then when we come down here and we see m equals 8, is that a before, is that a when, or is that an after? That's an after. M equals 8 is a positive number. So then our sentence can be something like 8 minutes after the tea was poured. The temperature was, what was it in this problem? 136.8. Okay, 8 minutes after the tea was poured. And then something quite similar for down here, m equals 7 is our answer. Is that a before, a when, or an after? It's a before. So what I say, negative 7 minutes before? 7 minutes before. Yeah, if you give me an answer, a sentence with negative 7 in it, it's not really a clear sentence that you're writing. I mean, the negative is going to be captured in that word before. So 7 minutes before what happened? The tea was poured. The temperature was, in this case, 142.8. We're going to see this whole before, when, and after thing written a little bit more formally in a coming class, but are there any questions at this moment? Okay, so keep going, pick up wherever you guys were before. Okay, taking a look at this first equation here in part C. Right here, I have 8 minus u divided by -2. That division line kind of separates these two pieces. And I need to decide, do I move the 8 first or do I move the -2 first? Which one moves first? It's the -2 actually. And the reason it's the -2 is that there's kind of implied parentheses up here. And so that 8 is not really accessible at the moment because it's trapped inside of parentheses. So we need to get rid of that -2. What's the opposite of dividing by -2? It's multiplying by -2. So I'm going to multiply both sides by -2. And then what happens on the left-hand side? Yeah, these guys cancel. Don't multiply that -2 through. Don't even think about distributing. You're putting that -2 there just so it'll cancel right away. So all we have is 8 minus u equals, and then over there is 6. Now that we've gotten rid of that division line, the 8 is accessible to us. It was kind of inside of parentheses before, but now it's available. So now we can move it. So subtract what from both sides? Subtract 8 from both sides. And that gives me -u equals -2. Right. Yeah, and then we saw this kind of trick earlier today. I would encourage you to multiply both sides by -1. If you have not just the variable, but negative the variable, I would just multiply both sides by -1. And so our final answer here, u equals +2. Okay, for part D, so let's stay together as a group for just another couple of minutes. I know people are all talking about the equations, which is a good thing, but hey everybody, can we just come back together for just a second? Thank you. I'm sorry to cut off such good conversations, but one word of advice here. It is very legal to distribute. Now, we have not used this word in this class, so clearly that is not what I'm asking you to do in this problem, but if that's something you are comfortable with, and you already know how to do it from some past math class, you're welcome to do it. Personally, I don't think it's the best way to solve the problem, but you can get to the right answer by distributing. But the way that I would really like us to solve that problem is to say, oh, there's a 2 times. What's the opposite of multiplying by 2? Dividing by 2. So I'd really love to just see divide by 2, and what happens to these 2's over here? They cancel, that's the point. And all of a sudden the problem becomes a lot easier. 8 minus u is all we have left. And then you do your division over here. I'm not going to go further with that problem because that problem is now much simpler. But what I wanted to convey was you do not have to distribute. If you don't even know that word, no worries. But if you already know that word and you feel like it's an obligation, I must distribute every time I can distribute, don't. I think there are better ways to solve these problems. Okay, so see how far you could get in the last minute of class. And again, I will check 2 homework assignments from you if I didn't check yours today.